We're going to be doing some examples of solving equations using inverse operations. So looking at our first example, it says that 1/3 of x is equal to 8. Our goal is to isolate our variable x, to which that means we need to get rid of the times 1/3. Now, I know that the inverse of multiplication is division. However, whenever we're dealing with fractions, a great strategy is to actually multiply by the reciprocal. Because if I have a fraction 1/3 and I multiply it by its reciprocal 3/1, reciprocal means, remember, you flip the fraction, then that actually equals 1/2, which is essentially a way of isolating the variable because the variable times 1 is just itself. So that was a little bit of an explanation as to why we are doing that. But in this first example, again, they are multiplying by 1/3. So to help get rid of that times 1/3, I'm multiplying both sides of the equal sign by 3/1. 3/1 times 1/3 is just 1. And 1 times x is just x. Anything times 1 is just itself. So I just have x left. And then 3/1, that's just 3. 8 times 3 is 24. So x is equal to 24 because 1/3 of 24 is 8. Our next example, 5 plus x equals 27. Again, we want to get x by itself, which means I need to get rid of this positive 5. Since that is a positive 5, I'm going to be using subtraction to get rid of it. So minus 5, if I subtract 5 from the left, I have to subtract 5 from the right, and that leaves me with x is equal to 22. Okay, third example, 2x minus 9 equals 6. This time we're going to have to do more than one step. So whenever we are solving equations, we are isolating our variables. The key is that you're doing order of operations in the reverse order. So instead of doing parentheses, exponents, multiplication, division, adding and subtracting, we're actually going in the opposite order. So I'm starting with anything that's being added or subtracted. In other words, I want to get rid of this minus 9. Well, the inverse of subtraction is addition, so I'm going to add 9 to both sides. That leaves me with 2x is equal to 15. Next, I need to get rid of the fact that x is being multiplied by 2. The inverse of multiplication is division, so I'm going to divide both sides of the equal sign by 2, and that leaves me with x is equal to 7.5. Okay, on the next example, I have 12 plus 2x is equal to 3x minus 1. So this time I have variables on both sides of the equal sign. I also have numbers on both sides of the equal sign. Technically, it's your choice which one you want to start with, if you want to start with variables or just your integers, but I like to start with my variables. It tends to make it easier for me. And I always start by removing the smaller value. And so I have 2x on the left, I have 3x on the right, 2x is less. So I'm going to start by getting rid of that plus 2x. Using inverse operations, instead of adding 2x, we're going to subtract 2x from both sides of the equal sign. And that leaves us with 12 is equal to 3x minus 2x is just x, and then I still have a minus 1. You'll notice that we have variables all on the right-hand side, but we still have integers on both sides of the equal sign. And so I want to get rid of now this minus 1 on the right. So I'm going to add 1 to both sides of the equal sign, leaving me with 13 is equal to x. Now our next problem actually has distributive property in it. You'll see that there's a 5 outside the parentheses, and inside the parentheses is x minus 2. That means that both the x and the minus 2 are being multiplied by that 5. So to do this, we create a box where I only have my number outside the parentheses goes out to the left, and then everything inside the parentheses goes across the top. So I have an x and I have a minus 2. And then we use multiplication to complete the box. So 5 times x is 5x, and 5 times negative 2 is negative 10, which means that 5 times the set x minus 2 is equivalent to 5x minus 10. And then we still have equals 15. Again, using order of operations in the opposite order, I'm going to start by removing this minus 10. Inverse operations tells me that I'm going to add 10 to both sides of the equal sign. And that leaves me with 5x is equal to 25. Next, I need to get rid of my times 5 by dividing both sides of my equal sign by 5. And that leaves me with x is equal to 25 divided by 5 is 5. Now I am skipping around a little bit. I'm not going to go over the next 2 slides, but I'm going to do problem number 2, letter B. It says solve each equation and check your solution. It does ask you to write the properties that justify each step, but that is not something that we are going to focus on during this assignment. Our focus is just going to be on solving. All right. There's a lot going on in this equation. I have variables on both sides. I have integers on both sides. I even have distributive property over on the left. So that's what I'm going to be starting with, is my distributive property. So again, whenever I do distributive property, I set up a box where whatever's outside on the left, whatever's outside the parentheses goes out to the left, and then everything inside the parentheses goes across the top. So I have 2 terms inside my parentheses. That's how I knew I needed 2 boxes. I've got 2x, and then I have a positive 1. Positive because it had a plus sign in front of it. And now I use multiplication to fill in my boxes. 3 times 2x is 6x. 3 times 1 is 3. So 3 times the set 2x plus 1 is equivalent to 6x. And then this is going to be plus 3. I knew it was plus because that 3 was positive. So 6x plus 3 is equal to 4x plus 6. Again, you can choose if you'd like to start by simplifying your variables or your integers. I like to start with my variables. It makes it easier in the long run for me, so I don't wind up with a negative in the end that I have to deal with. And I like to get rid of the smallest value. So I have 6x's on the left. I have 4x's on the right. So that means I'm going to get rid of this positive 4x. To get rid of a positive 4x, I have to subtract 4x from both sides. Remember, you can only subtract like terms. I can only take x's from x's. 6x minus 4x is 2x, and then I still have a plus 3. Bring down my equal sign. I still have a positive 6. Now that all of my variables are on the left, I want to move all of my integers to the right. So I want to get rid of this plus 3. Inverse operation says I'm going to subtract 3 from both sides. And that leaves me with 2x is equal to 3. Finally, to get x by itself, I'm going to divide both sides of the equal sign by 2. And that leaves me with x is equal to 1.5. Now, we do want to check our answer to make sure we did it correctly. So I'm going to plug x is 1.5 back into the original problem. So I have, 3 times the set, 2 times 1.5 plus 1 is equal to 4 times 1.5 plus 6. So now we are doing order of operations, PEMDAS. I'm going to start with my parentheses on the left-hand side. 2 times 1.5 is 3. So I have 3 times 3 plus 1 is equal to 4 times 1.5 plus 6. Okay, further simplifying, inside the parentheses, 3 plus 1 is 4. So 3 times 4 is equal to 4 times 1.5 plus 6. 3 times 4 is 12. 4 times 1.5 is 6. And then finally, 6 plus 6 is 12. 12 does equal 12, so we know we did it correctly.